In this video, we're covering limiting sum of an infinite geometric series. So we're going to cover some terminology here. So the limiting sum is the limit where it exists of a geometric series as n approaches infinity. Diverge is to have no unique limit or to have infinity as a limit. Converge, to approach toward a definite value or point. In some geometric sequences, the sum becomes so large as n increases that we say these series diverge, which essentially means their sum is infinite. In other geometric sequences, the sum doesn't actually get bigger, it gets smaller or approaches some constant value. So we say these series converge. They have a limiting sum that's a specific value. On your screen, you can see in red a formula. This formula can help you find the limiting sum. Now, limiting sum only occurs when that r value is less than 1. So we're going to answer some questions here. So which series has a limiting sum? And then find the limiting sum. So we start by finding our r value. Now remember, your r value is what is known as the common ratio. So we do that by, remember, t2 divided by t1. In this example, I'm actually going to do 1 divided by a half because it's a simpler operation. So we get an r value of 2. So since r is greater than 1, no limiting sum. Because remember, your common ratio needs to be less than 1. Alright, so we're going to try this one and we'll do the same thing. Let's find our r value first. Alright, since r is less than 1, we can use this operation. There will be a limiting sum. Now remember, your formula for that is where a is, as always, is our original, the starting value. So 16 over 1 minus 12 4/5. So that is the limiting sum, which means that as we're getting smaller and smaller, eventually we'll get to this number and it'll become so close that we will not notice a difference. So find the limiting sum of each series. So the same thing, start by finding our r value. So our r value is 1 over 4. We then can use our formula to find our limiting sum. Alright, we'll do the next one. Same thing, find your r value. Alright, next question. A geometric series has a limiting sum of 5 and the first term is 3. Find the common ratio. So we'll be using this formula. We know the limiting sum is 5. We know the first term is 3. We're going to swap these positions. So we get 1 minus r equals 3 over 5. So minus r will equal, and because there's negatives on both sides, we'll cancel those out. So the common ratio is 2 over 5. Alright, a geometric series has second term and fourth term. Find A, R, and its limiting sum. Alright, so this involves some formula from previous. Alright, so we have two equations here. The first one we know is going to be 2 over 3 equals AR. And because it's the second term, it'd be 2 take away 1, which is 1. But we don't need it there. I'm also going to tidy up that R. The second equation is where we have 8 over 27 equals AR. Because it's the fourth term, it will be 4 minus 1, so 3. And then we can do some simultaneous equations here. If we divide equation 2 by equation 1, we'll cancel out the A's and we'll be left with just R's. So R squared is going to equal 8 over 27 divided by 2 over 3. And that comes out as 4 over 9. We can then square root both sides and get R equals plus or minus 2 over 3. We can substitute this back into the first equation. So the first equation was 2 over 3 equals AR. We know R now, so we can say that we can then divide by plus or minus 2 over 3. So A comes out as 1, plus or minus 1. We now know that we can say A equals 1 and R equals 2 over 3. And we can find our limiting sum there. Oh, sorry, equals 3. Because we had another plus minus 1 for our first term, we need to do it again with the negative. The same formula. So we have two limiting sums. We have one at 3 and one at negative 3 over 5, depending on which, if you're using negatives or positive values. So we'll do a quick recap. So remember, if the sum is going towards infinity, we call that a diverging series. Whereas if the sum is going to a set value or a constant, we say it's converging. When it is converging to a limiting sum, we know that the R value is less than 1. If it's greater than 1, there is no limiting sum. It will go towards infinity.